notifications. Clearly, I didn't the entire day.
Oh, I've only got USB-C.
Please stand by. Here you go. And here is, if you put that on your jacket. Perfect. Thank you.
Hello, hello. Hello, hello.
Yeah, you're good.
Yep,
It
cool.
just records the video.
Hi everyone, my name is Samantha, as you might have seen on the slide. I'll just give a couple of caveats before I start going into my talk. This will be the least rehearsed of any of the wonderful presentations you've seen so far, because I only got notified that I can talk a few hours ago. But I'll try and work my way through it, and hopefully you guys can be a bit lenient on my presentation, and we can work through this together. I can bring up the title, or I can talk through the title, but I can't remember the exact wording. I know that for my talk, I'm going to be talking about two things. They're kind of separate, but I'll see, they kind of interact with each other. The first thing that I'm dividing my talk into is the large Apple Health XML files and how to deal with large files in general, in particular large XML files. The next half of the talk that I'll be talking about is using Julia in particular for this task in general of analyzing this kind of data, as opposed to using R or using a database type system or using Python, what was your name again? Jen. Jen already discussed Python. This is Python in a different way. This is more like strictly data. But yeah, I'll discuss how the languages, the similarities and differences. Also, in terms of just the scope of the talk as well, I will say that in terms of this meetup group, it is data, and one of the topics within the subtopics within data is memory management. And this presentation will touch on those issues, because when you're dealing with large XML files, the size of the XML file can exceed the computer's memory, the RAM, in which case prudent or parsimonious memory management becomes crucial to get some analysis done. So firstly, I'll discuss Apple Health in general. Does anybody at all collect data on just themselves? So for example, do you track your sleep? Do you track your workouts, your walks? Some people might count calories. Yep, we've got one. Jen, what do you do?
I use it all. I'm an Apple nerd.
Oh, so
Everything else is like Linux. I'm like, Apple, sorry, Apple all the way.
Okay, so you've got an Apple Watch, or? Okay, I don't see you wearing one.
It's hidden.
Oh, you've got it right there. Okay, so that's great. So this might pertain to you. Other people might be on Fitbit. Other people might be on Garmin. There are various ways to track your data. There are various devices to track your data and various metrics that you can track. If you want to look at that data and analyze it, you can go to the independent trackers themselves. For example, if you've got a specific thing like a Whoop, that might only do your sleep, or that might, like a Garmin, might only do your workouts. But the thing with Apple is it just agglomerates everything. So you've got one central repository, because the Apple Health, it's got an API. These terms might be a little bit alien to me, so I might be using them incorrectly, but I'm just kind of guessing my way through it. So the API connects to the other services, and then it all agglomerates into one place. So my thing is, or my motivation was, once you have all that data in one place, analyzing it in that specific repository rather than going to the individual places where you might only look at sleep or you might only look at nutrition. If you can combine the data sources into one, then you can see the relationships between these two data. For example, you can see theoretically how your sleep affects your nutrition, or your workouts might affect your sleep, or something like that. So when it comes to the data itself, usually when it's only from one service, they'll be quite nice about having you download it from them. they'll typically give you a CSV file because they're not collecting that many fields of data, or the data is quite simple in its structure because it's only one service. But when you've got an agglomeration of data, for example, how Apple Health does it, it's not very approachable. It can be quite difficult. And I've got the file on here. We can just look at it. This is what it looks like. It's called export.xml. And yeah, you can already see like did you see like the little scrolling thing? Or like that just shows like this is a really big file. I'm on an Apple MacBook M2, and like if you're not prudent with the memory management, the computer just struggles with like parsing it or like just looking at it at all. You can see it's 2.27 gigabytes. So with a file like this is about 4 years worth of data, thereabouts. You can't just open it. Like I naively first, I was like, oh, okay, let's just open it with this and like see what happens, like and just see what's going on. You can't. That basically crashes the computer, or like, it's not. I think my RAM might be about 16 gigs or thereabouts, but this should be able to handle it. But like the computer just freezes. So how do you even know what you're looking at? I had to discover that. Wait, where am I? So basically, you have to use the terminal to even try and understand what we're dealing with. Perhaps. How do I do that?
Like Command plus maybe?
Okay, great.
Oh, much better. Thank you.
So we need to navigate to the phone. So this is the file name, export.xml. And we can't open it using text edit or like even like your Excel or like even any type of file opener. You can't view what the contents. You have to use the terminal and terminal commands just to figure out what we're dealing with. And there's a Unix command. Some of you might be familiar with it. It just allows you to see the first few lines. This, from my analysis, this is about 7.5 million lines, but there's like just the first 100. And with any XML, have you used XML files before? Yeah. So the way Apple structures the XML file is they give you DDT at the front, matter. This is what that is. It's quite extensive. And you need to understand the DDT syntax in order to analyze the file. You can't naively go through every element, because if you do, as some people have done, we can get on this later, you'll miss out some of the data, or you'll skip over it, or you'll analyze it incorrectly. And if we open it up a bit more. So this is still DDT, so like the first 200 lines. And then we get to the records. So some of them. What Apple does to make it really difficult for you is like, you might think, oh, it's just a bunch of nodes, and we just need to like go collect all of the nodes. But that'll lead you astray, because the way it works is they have it so that they've got the data stored in the node, but then sometimes they nest elements within the node itself, and you're not going to know that unless you like look through the entire file, and it's hard to look through the entire file because it's so large. So anyway, this is a mess. And what I want to do is I want to get a bunch of data frames, because I'm used to data frames, and I know how to analyze data frames. I can graph from the data frames. With this is just difficult to get a handle of what I'm even looking at. So now we can go through how other people have looked at this data in the past. How am I going for time?
You got about 10 minutes.
Oh, okay.
And hopefully nobody's getting too distracted by the food. I know. I was like, I was doing good. I saw it, and I was like, no, now
I mean, you can go through it interactively. This is like one of the people who's done it. We can go through their source code here. One of the main things I'll say about this person and what they've done, when it comes to XML, the people who've worked with XML before, the main way to, or like the classic way to parse XML is through the document object module. structure. That's what this person does. The problem is when you've got data that's big enough, it crashes the computer. It's the same issue as like when you try and view it with TextEdit. It's just too big. So like, or that doesn't necessarily happen with this person, but like I timed it. It takes about 50 minutes just to like, for example, this line of code, because it's just so much. And in addition to potentially crashing the computer, it just takes a long time. And there are ways to like make the process more efficient. So now we can go on to the next person and their approach to parsing this type of file. And it just happens to be in Python. This is the repository on GitHub. And this is what the code looks like. Basically, going back to what I said earlier, you can't naively pass through every single element. And that's kind of the approach that this person does. And I think it leads them astray because it leads them to miss data and it leads them to combine the end result into like one big table, which is very sparse because some of the fields don't necessarily pertain to every element and that kind of thing. And so if we go back to the terminal, we used head before, and now we'll use tail.
I thought you said that the DTD is at the top.
Yeah,
So
but I just want to.
You've got the structure definition at the top.
That is true.
So why would you put it all into one table and push the sparse?
That's just the approach that the previous person did, which I don't agree with. So as you can see, the data can be quite nested. It's not like how it was at the top, where it's just like element, element, element. There's a nesting structure as well. And in order to not miss any of the data, you need to pass all of that properly. So for that reason, we use something called an iterative parser. That's what this person actually does. And it's faster, so that's one of the benefits of doing it that way, and it doesn't crash the computer. Let's see. And my approach was to use Julia for this task. Well, this is before the previous person, the R package to look at XML data, I believe the package only allows the document object module way of looking at the data. But in Python, there is something called an iterative parser, which is the correct way, which is what this person uses. My approach is to use Julia instead, because my argument is you can't escape iterative parsing because of the nested structure, which I talked about earlier. You can't use list comprehension to just get all of it in one go. You need to iteratively, painstakingly, element by element, build your document. The problem is Julia in general, it's not a very mature platform compared to Python. So some of the packages, they're not really quite there yet in terms of like just being user-friendly. The last few years, this is sort of the main XML parser that Julia's had. And this is the main, when you have the DOM parser for XML parsing, it's really nice because you can use, is there anyone familiar with XPath? Or like familiar? So the way that you would like look at HTML document or data or anything like that, you don't even need to like end up with a table. With XPath, it's really fast. It's almost like a database query. Like it's just instant and you'll get all of the data that you can possibly ask for like instantly. Whereas, but the problem with that is like when the files are too large, you can't use XPath and you can't use DOM. And the streaming API, so this is the iterative parser. I can scroll down. They're not that nice to use because they don't have the same features that the mature DOM way of looking at data has. This is quite limited in terms of the functions, the API, the functions that it has compared to if we scroll up. Yeah, this has a lot more that you could use. But that changed recently with a new package called XML.jl, which is what I use for my sort of project. It allows you to use list comprehension if I go to to get all of the tags, all of the attributes, and all of the children in one go. And this is quite fast. It's faster than how, I didn't benchmark it because I don't have time, but it'll be much faster than R because R is very slow when it comes to looping. And it's slightly faster than Python as well, but I didn't benchmark it to confirm, but it just feels that way. So after you get all of it, all of the data just dumped into the computer, after that, going back to what I said earlier, you need to like painstakingly, element by element, build with a loop, getting all of the tags and all of the data from every element as part of the element, and then go into the next element. And that's what this loop kind of does. Currently this doesn't do much because I've just sort of ignored the problem. I've just like sort of discarded it. But eventually, with one of the ifs, one of the conditionals, I'll create a dictionary. In general, so when we go back to what the data looks like, the way to go from this mess to a data frame is you go from here to a list of dictionaries or a vector of dictionaries, and then from that dictionary list, go to a data frame, and then eventually to a CSV file or something like that. And that's what the loop that I'm showing here kind of does. It'll be element by element, and then within every XML element, just extracting every single header, every single field, putting that into the dictionary, and then going on to the next. But the problem is also that the data is unstructured. So there are arbitrary numbers of like elements, like within the nesting structure. So the data frame that you end up being, even if you can create it, it would just be a bit of a mess because it won't be like, data frames are nice when it's like the same data for every line, and it's like the same number of headers for every line and stuff like that. When you've got like an unstructured amount of data, then you have like an issue with like the wide to long, how do you even present it? Then you have like duplicates, like duplicate headers or like duplicate like cells containing like the same data. But I feel like the end user should be able to have that choice. So that's what I'm building into my package, which isn't quite done yet. But yeah, once it's finished, the end product will allow the end user to do that. And this is done through Julia. I don't know if anybody has made a package before or thought about making a package. It's quite difficult in R and it's quite difficult in Python. But I can evangelize. How am I doing for time?
You're at time, but I figured
Okay.
if everybody's cool, we could give them a few more minutes. Okay.
This will be the last thing I'll say. Julia is quite nice when it comes to package creation. It's not as difficult to do as Python or R. The registrator, like it's quite lenient that way. So you can create a smaller package without having too many functions and just throw it into the general registry. And then once it's there, you don't have to like call it from like your computer. You can just call it from the internet. And that's quite fast. And it's quite convenient as well. So that will be another advantage, in my opinion, of using Julia compared to Python or R. Okay, that's all. Thank you.
I need the mic back before you leave.
Oh.
I don't need it right now. I just need it.
No, I don't have no need for this. Cheers.
I put it on by default. Simon, do you want to close this out, or am I good? It's up to you.
I was going to say, up to you.
Oh, well, I'm here, so might as well. Now I got to figure out how.
So while Jen's figuring that out, we've also got a lot of pizza there, so we will need your help to consume it. So yeah, feel free to stick around and have a chat.
Hey, okay. Yay. Feedback is a gift, so if you want to leave feedback for us, please click this link. Yeah, this is definitely, click this link specifically. Yep. QR code. I'm glad y'all know how to do what the screen says, not what I say. If you want to be a speaker at a future event, you can follow this link. And very last but not least, We'll leave this up for the duration of the time, and if you would like to try out Ivan, this is the QR code that I listed earlier, so that way you can get more credit to do so. And thank you, everyone. Can we do a round of applause for everybody? Because y'all showed up. Yay.
And come get some pizza.